of combine and something like Rx Swift is one of the key differences between combine and something like Rx Swift is that combine really cares about the types of the errors coming through. And it also, every operator you apply to your stream changes the type of that stream. And since Swift is very picky about types and the type should match, we have to go ahead and set the failure type to error, because the gist object itself will not have any error at all. So it's a stream that can't error, can't possibly error, because you just went ahead and said it's always going to be this empty array. So we go ahead and set the failure type to error, and then we erase to any publisher. And so, like I said, when you apply operators to your stream, it changes the type. Erase to any publisher just goes ahead and it's going to end up changing the type of the return value back to what we expect, which is in any publisher of type list of anime and error, as opposed to something else that would be something like a gist object wrapped in a failure type setting object or something like that. I'm not sure exactly what they are under the covers. So that's one special case we handle. Then if the query is not empty, we actually perform the request. So we hit the API search/anime. We send the Q parameter, the query object, in the Q parameter. And then we get the result keyed, or the objects keyed under the results node. The anime object itself looks like this. You can see, let's go ahead and search Dragon Ball again. So this is all the data that comes back in the web service for an individual anime. We're only using a few of the fields, but if there were more, we could add them here and use them as we need to. So Swift has this pretty nice protocol called decodable that anime adheres to, and that allows us to pretty much seamlessly translate that JSON into actual anime structs without having to do any of the heavy lifting ourselves. So any questions on making the request to get the list of anime objects? All right, let me go ahead and look at the search view. And I'm going to hit resume here on the top right. So one of the cool things about Swift UI is you don't actually have to build and run the app in the simulator to see your updates. So I can change this navigation bar title, and it reflects immediately on the screen, kind of like what you've probably seen with React Native and Flutter. I think they do very similar hot reload type things. This isn't that exactly, but it mimics that behavior pretty well. And it's super useful as long as it doesn't, as long as you don't write an error in your code that actually crashes the preview and then causes you to need to restart it or recompile, which can be kind of frustrating if you're doing this all day.
And then, Jim, that's also because of the preview provider, correct? That's actually the object that's returning all this kind of stuff. And usually with the preview provider, you just return the struct that your live app would return.
Yeah, so let me go into that a bit. So as you notice, there's nothing showing up in this list right now. But we could go ahead and add. Oh, actually, there should be things showing up in this list right now. I'm not sure why they're not. Let me see. But yeah, so the what I was going to show you next is that the preview is actually driven by this struct that will actually get generated for you. So I'm going to delete it. If I say create preview, Xcode looks at what file I'm in, and it goes ahead and creates this struct, this search view underscore previews. And it uses the preview provider protocol that Jason was alluding to. And you can go ahead and fill in whatever SwiftUI views you want here and hit resume. And now it should show me hello world. So that's not actually my view, but it is the view that is here by default. So let's go ahead and replace that. Let's see if I do this right. So the search view takes a model, view model, and normally Xcode would be auto-completing this and making my life easier, but it's not doing that. So let me see if I did this right. No. So the search model, this parameter is unnamed. Okay. So I went ahead and ran that, and we're back to this empty list. So what I actually expected to see here is, so my preview search service, it goes ahead and returns an array of this single anime 100 times, which isn't super useful for real world applications, but is useful when you're just trying to preview what's going on. Let me look real quick and see why this isn't actually showing anything. I think this might be why. So our query is never actually updating. So in the actual app, as you type, it's updating a query string, and it's kicking off this chain that I actually wanted to get into in a later part of this talk. But the preview window isn't getting any queries coming through, so it's never actually updating, and it's not kicking off that request. Let me see.
Did you click play on your preview?
Do I have a play button in Xcode 11? That's
It's
Xcode 12, right?
It's right down there at the bottom right.
Okay. It is not playing. Or at least it's not doing anything. Projected by deep bounce. Let me just, oh, you know what? Breakpoints aren't going to work in my preview window.
You could still do like a print to your console.
So the stream will print through the.
I don't know if it will or not, but if you wanted to like put it, oh, I guess you're right. A breakpoint would help more.
Yeah, I'm not sure. All right, yeah, so so typically your view, and I guess we could change this up really quickly to just take let's see. Yeah, typically you would just pass your structs through to your view or your model with the structs pre-populated, which is what I was attempting to do here. And they would show up in the preview window, which is actually super useful. And maybe we'll come back to that later and see what I broke there. Yeah, but for now, I think I'm just going to keep moving forward. and show you how this is laid out. So the search view is a navigation view, which allows for standard iOS navigation. So if you're familiar with how the back button in every iOS app is pretty much the same on the top left of the screen, that is actually provided out of the box. And navigation view is the component that does that with SwiftUI. Next thing we have is a list. The first element in the list is a search bar, which we'll dive into momentarily. The search bar actually takes a binding called text that we're binding to the view model's query parameter or query property. If we just access viewModel.query, we would just get the string itself. But to turn this into a binding, we've added this $ here. And what that's doing is creating, and of course Xcode won't command click into anything. What it's doing is creating a two-way binding between the value here and what the user is typing and showing up on the screen. So that's the search bar component itself. And then when you actually search, oh, what did I do? Oh, my breakpoint just fired. That's cool, considering I got rid of it.
Jim, it also says that where your preview is, it says in the upper right-hand corner, it says the automatic preview updating is paused. I don't know if that means anything. But...
yeah, so what I mentioned earlier about sometimes the preview window gets broken and you have to manually hit resume. It's kind of annoying.
Oh, gotcha.
That said, I'm still not sure why this data is not showing up because yeah, that I fixed that and it's still not there. But yeah, we'll look into that in a minute. So looking at back to this list object, the list, you can just add as many things as you want to it. So I can just add a new text object here. And each one of these is essentially gonna behave like a cell in the old UI table view world or the old UIKit world. And in fact, under the covers, that's pretty much what SwiftUI is doing. At least for now, the list component is just translated to a UI table view, which is familiar to you if you've done a lot of iOS work before, or maybe even just a little bit, because that component is so ubiquitous. So each of these becomes its own cell. If I toss them in a container view, so I've gone ahead and put these two text values into one HStack, that container becomes one cell. So, and as you can see, all of these are pretty much different types. It's pretty flexible. It lets you do pretty interesting things with different views. One of the things we really want to use the list for are to display dynamic data, arbitrary lists of dynamic data. To do that, we use the for each view. So for each, we'll take a list of objects and then some way to identify them. And to ID them, the object just has to implement the identifiable protocol. So if I look at the anime object, which, yeah, that's not going to work still. Okay, so the anime object, I have it extend identifiable, and to implement identifiable, you just have to implement this ID protocol, and the ID that I'm returning here is one of the IDs that comes back in the web service. So that ID should be unique to that single anime. And SwiftUI can do really interesting things with that, like if I search this list, I'm going to search GT, and it actually moved. If you saw Dragon Ball GT is here, it's actually going to animate that up to the top of the list without recreating that view. Behind the scenes, SwiftUI is diffing the old data set and the new data set. It's using that identifiable protocol to recognize which objects are the same in each set and then trying to do the right thing around making it show up on the screen the way it should, which might mean animating it on or off the page, even as it's doing other transitions, which is pretty neat.
Is that an iOS 14 feature, or is that done with
iOS 13?
Okay.
Yeah, so in all of this is iOS 13 specific. I didn't have time to update this to iOS 14, and Xcode 12 for iOS 14 actually just released yesterday, the GM of it. It's actually, I don't even think it's officially on the App Store yet. Maybe it is, I can't remember.
I think it just came out because it downloaded for me this morning.
Okay, yeah. So it was kind of a.
Hey Jim, I didn't download it yet, but I'm wanting to know if you fed the dog.
If I fed the dog?
Yeah. Yeah, did you
I
feed
did
the dog
not.
today? You didn't feed the dog today?
No.
Okay.
Fed him.
All right, good. I'll make sure to download it. But thanks.
Is this a dog fooding joke?
No, Amy just texted me and asked.
Oh, no, I have not. I did not.
Okay, thanks.
No problem. Amy says, thanks, Pete.
No,
So in this for each, we've got a VStack that represents our cell. That's our anime object. So, and it's pretty basic. It's just a VStack, a vertical stack of 2 text objects. And one of them has a modifier on it that turns it into a footnote text, so it makes it smaller. This isn't too bad, but a lot of times we'd like to make our views a little simpler and maybe more reusable. So I'm going to go ahead and define a new struct, anime row. And I can take this entire VStack, dump it in here, and define a property anime on the struct. And now, hopefully I did this right. It's a little tough because I don't have any feedback from Xcode right now. Just Xcode things. But now I've gone ahead and made a new view, very small, very lightweight. You saw how easy it was to just cut and paste that. Imagine the old days of UIKit making a custom view like that. You'd open up a new class, and maybe if you're using Objective-C, you've got a header and an implementation. In Swift, you've at least got a new file, most likely. You've got to implement the proper initializers. You could need to hook it up to a knit with Coder or make it work with storyboards. We're eschewing all of that. We just cut and paste 3 lines of code and added a property and created a struct. And now we have a whole new view. And now this view could be used anywhere else in the app. All it needs is an anime object or struct. So that's how the list works. It's going to loop through all the animes in the view model and put a row on the screen. The navigation bar title, I already kind of showed this off, but you can do whatever you want here, and that's what shows up in the top of the navigation bar. And then we've got this alert piece. So I mentioned earlier that the publishers can fail, and that's why we have an error type. What this alert is doing is, in the case of receiving an error, it's going to go ahead and display that to the user. Pretty generic stuff right now, but it's kind of cool the way SwiftUI handles this. You just add this alert modifier to any view, tie it to some object, in this case an error message, which is a string, and then you just return an alert struct, which is just another SwiftUI view, and SwiftUI will handle showing that and dismissing it and doing whatever actions are required when whatever button is pressed, as you define it here. The only thing And again, Xcode's not going to autocomplete anything, so it can't easily show you this. This item has to be identifiable. There's actually a couple different ways to do it. I find this the simplest. The way this works is, let me pull this up in the model. We have this error message string that is optional, so it can be null or nil. I have extended string to be identifiable, which I mentioned earlier. Switch UI uses to diff elements in the list and determine which ones are different than others. Switch UI also requires this for showing alerts, that the item be identifiable. So I just cheated and made string implement identifiable, which I think is a fairly safe thing to do, but typically you wouldn't want to implement a protocol you don't own with an object you don't own. But in this case, I think it's fine. And what this is doing is, if this is not nil, it's going to show it. And then whenever the user does something that gets rid of the alert, it sets this value to nil. And if you look here, it's the $ again that we used earlier. What that means is it's a two-way binding, and that's what allows alert to actually go ahead and set the error message to nil when the user is done with whatever they need to do with that error. So that's kind of neat. What this looks like, these bindings, you can see in the search bar. So above, we created a search bar and we bound the text with the view model's query object or property. What that looks like in the search bar itself is @binding var text string. So that is a pretty easy way to make it so the search bar, which is owned by the search view, which has a reference to the view model, can all talk to each other, and it's pretty seamless. Like, I think it was more complicated the way I just explained the object graph than it actually is to see how they interact, right? We just pass a binding and it does the right things. Another thing the search bar has here is this is editing property. So when I hit cancel, is editing is set to false. When I tap into the view, is editing is set to true. So that's the way the search bar can keep track of its internal state. Going through this view, it's a horizontal stack. So we talked about a vertical stack earlier. This one's horizontal, so it just goes side to side. It contains a text field that says search for anime by title, which is pretty light, so maybe you can't see it too well, but it's the text that's inside this box. There's some styling to it. And then we also capture whenever this view gets tapped, and we set is editing to true. The next thing in the stack, if is editing, so if is editing is true, we show a button that the action, when that button is tapped, sets as editing to false. It clears out the text, and then it does something to force the keyboard to dismiss. The text on that button is cancel. And I could add more here. You could add an image, image, system name, person, Bill, I think. I'm trying to remember a name of of some of the system icons. I may have got that wrong. Okay, I got it right. So that's kind of neat. So this button here, I can just put some views together, and that's what's going to display on the button. A lot simpler, really, than what you used to do with the UI buttons. I'm going to go ahead and delete that because it looks a little silly. But that's how that whole view is built. Now I want to show you something. When I click into here and I hit cancel, try to watch this animation, or maybe the lack of animation. It looks pretty funky. Hopefully you can see it. But the view just kind of immediately juts over to the right, and then the cancel button lazily, the text disappears to the screen off to the right. You wouldn't really expect that to happen, especially with a framework that's so nice about animations and it's trying to do everything for you under the covers. So it feels like you don't have a lot of control. It just usually does the right thing. What's actually happening here is you need to tell the framework when to animate a change. So we're making 2 relevant changes to state here by changing the is editing property and the text property whenever cancel is tapped. If we want those to animate nicely, we have to say with animation and pass a block. And now hopefully the system does the right thing. So now this box goes off to the right side, but it does it at with the same timing as the cancel button. So hopefully that's visible through the stream. I know it's probably difficult to see, but just be cognizant of, you know, when you're changing state and you want things to move around the screen, you got to make sure you call with animation. All right, gonna jump into the model here, which I kind of glossed over earlier. So the search model is an observed object for the search view, which means the search view gets instantiated with one of these. And anytime any specific properties, and I'll go into which ones, on the search model object change, this body will be called again, and Swift UI will do a diff on the hierarchy of the old body and the new body, and it will perform whatever relevant changes it needs to in order to display the new state. The reason it needs to do the diff is it's got to handle animations and things like that. If we didn't care about that, it could just display the new state right away. And the other thing, part of that is maybe a lot of things don't need to change at all. So it doesn't need to re-render as much if it doesn't have to change certain views. It can just re-render the stuff that has changed. And I know a lot of those optimizations haven't actually been done yet on the Swift UI side, but the possibilities of getting a lot of performance boosts are there. Right now it's pretty, I'll say, re-render happy, and it doesn't need to be. So the model itself, to make something, to make it so that it can be an observed object, you have to have a class that implements the observable object protocol. In what that's doing essentially is it's going to report specific changes up to whatever is looking at it. And here we have 3 properties that are all published. This published annotation is essentially telling Swift UI which things it should be looking for when this observable object updates. So if I got rid of @published here, query when it changes would not cause a re-render. It actually make the code not compile because we're relying on that to do some bindings and things like that. But if I just add a new property here, and I change this, the search view will actually, even if the search view is not looking at that, it will perform a re-render because it's looking at this observable object, and it will, well, sorry, I shouldn't say re-render. It will look at the body again whenever this value changes, and it'll do the diff and determine whether or not it needs to update. And since I'm not relying on foo for anything in the search view, it would never actually do an update. But that's what published is doing for us here. This model is basically handling the search interaction and not much else. So it gets instantiated with a search service, which we kind of talked about earlier. It takes the query's projected value. So what that means is it's essentially turning this published var into an any publisher. So something that we can kick off a reactive stream from. It is debouncing that stream. So what that means is as I type, it's not actually making requests right now. It's not searching for anything until I stop for a long enough period of time, and then it actually makes a request. So I've got this set up here to debounce for 0.3 seconds. So only once I've stopped typing for 0.3 seconds does it actually, sorry, trying to think of a different anime to search for. So I searched for Vampire Hunter D. Only after I stopped for 0.3 seconds did it actually make the web request to begin the search. It takes that query that we get after waiting and maps that into this request off of the service object. So the service we passed in earlier takes a query. We're sending that query to the service. It should be hitting our JCon service and actually getting JSON from that API. And then we're doing some fancy stuff in here I'm going to ignore for a second. But thing to keep in mind is this mapping is making that actual web request. Then we have this switch to latest here. What that means is because we are mapping the value of the query to another publisher, the switch to latest is saying, if I get a new publisher, which means the user started typing something else, cancel any of the old, or cancel the old publisher. There should only ever be one at most. Cancel that and connect me to the new publisher. So that's pretty handy as you're searching. It's not going to keep frivolous web requests around. It's going to go ahead and cancel them as the user's typing. And then we call sync, which actually allows us to receive a value. So as I mentioned, reactive streams have a way to get values, to throw errors, and to be done or finish. This is how you handle just receiving a value. It's one way to handle receiving a value. And what happens here is we're setting the anime's property, this published property, to whatever we receive from the web service. And then what a sync does is it kicks off the work and it returns a disposable. So if we don't call sync here, none of this work is actually gonna occur. It's just gonna be, if you're familiar with a promise or something like that, it's a bundle of work that can be done in the future. And sync is, when that's called, that's actually kicking that work off. It returns a cancelable, which is an object that allows you to cancel the stream. A very common way to handle cancelables is to create a list or a set of cancelables on your object. So search model here, I've got a list, a private list of any cancelables, and you just store the cancelable in that list. And the reason we do that is when this object is ready to be deallocated, it'll empty that array, and when the cancelable gets deallocated, it will actually cancel the stream. So that's how we kind of handle memory management with Combine. So this is basically how we handle the search functionality. I'm going to go back to this error handling. We don't actually have to handle an error down here because this chunk of code here, line 21 to 27, actually makes it so we never get an error out of this stream, which makes it much more convenient when you actually get to the termination case down here. But to make that work and help our users out a bit, we do need to catch errors, which we're doing here. Still returns an any publisher of a list of anime, but this time we put never as the failure state. And in this case, whenever we do get an error, we set self.error message to whatever error came back from the request, which is probably not what you would do in a real app, because your user deserves something a little better than some JSON decoding failure message or something like that. But I figured for this demo, it's fine. And then we just return an empty any publisher. So with that done, we have the ability to, if the web service throws an error, display it to the user right away. So let me see if I can do this time. I do not remember the initializer for an NS error. Let's see if I can do this. Sorry, I should have typed this up before I decided to show everyone. Yeah, so just like there is a way to just pass an empty array, for example, there is a way to just send an error through, and I was pretty sure that was called failure, but that doesn't seem to be working. So let me look. Maybe it's just called.
Hey Jim, I think it's just called fail.
Fail, yeah. And that's going to give me an error here because I still need to erase to any publisher. And let's see. Okay, so that actually built, which is nice. And now the request was made. That string error message on the model got set, and now we get an error alert. So that's what I was showing earlier here. And now you've seen it all the way end to end with the web service returning an error, the model setting the error message, and the view showing the alert. And when I hit OK, Swift UI set the error message to nil, and now the error has gone away. So that's kind of a basic structure of an app that has search functionality using reactive streams and done in Swift UI. So Pete did an excellent write-up for the meetup this month, and I know in it he mentioned something about best practices, and I think we could definitely discuss whether or not some of these are best practices. But I would say the way that the search model is done, I really like, and it's an approach that has worked for me in many different apps over the years. And I think that there are some good rules of thumb in here. So debouncing as the user's typing for a search, I think that's great, to wait until the user's done typing before you actually try to handle their request. Canceling previous requests with switch to latest makes it really easy. Using reactive streams like this makes it really easy to just cancel the old thing and start the new thing. I think that's a great approach. I like avoiding having to handle errors downstream at the point of trying to receive the data that I actually want. So I also like this approach here of mapping to the service from the query and setting an error state, and then just returning some basically ignored value in this case, but you could do something, any value through your stream you need to get it going. But as long as you handle your error condition up here, I think that's a good idea. So if we're talking about best practices, I would say those are best practices. As far as the laying out of Swift UI and how I modeled the data, I think we could quibble about that. So any questions on this? Has anyone done anything like this without using something like Combine or Swift UI?
Oh, I just had a question about the cancelables. Someone
Sure.
hasn't. Yeah. So where are the cancelables actually recycled? Is that just by default? Is the cancelables themselves like just handled automatically, or is that?
Yeah. So objects in my autocomplete. Oh, it's working now. I have autocomplete. Cool. So objects in Swift have a function called dinit, kind of the opposite of init. And this is where what gets executed right before their memory gets reclaimed. Cancelables, when they get deinitted, cancel themselves. So the act of storing the cancelables in a list on the object whose life cycle I want that cancelable to follow. Yeah, it's kind of a weird concept, and I haven't really seen similar things for memory management in other languages, probably because they're using like garbage collection or completely manual reference handling.
Okay.
But Swift is using ARC, automatic reference counting, an Apple technology. And as a consequence, as a developer, you end up doing a lot more to handle reference cycles. So I didn't even talk about unowned self here and unowned self here. If I didn't add these references to self would essentially the reference count to self would go up because this closure would keep a reference to self and own that reference, which would be actually very bad here because self also owns that closure, and that would create a cycle, right? If I own a closure and the closure owns me, the memory could never go away. So in Swift, you do things like unowned self to make those things clear and make sure things don't get over-referenced.
So by having the cancelables on the object, do they deinit faster when that object goes out of memory? Is that?
It's not about speed. It's kind of about convenience. So if I didn't do this, well, I could just keep a reference to all my cancelables, and then for cancelable and cancelables, I could cancel them, right? Like I could manually do that, but because I'm just tying it to some list that the object owns and storing it in there, the system handling it for me. That's all it is.
Oh, okay, gotcha. Cool.
And if you don't save the cancelable, then the request just disappears into nothing.
Right, because the cancelable.
I found that out the hard way.
Yeah, so if you don't hold on to the cancelable, it's the same thing that I was talking about a minute ago. The cancelable just gets deinitted, and what happens when the cancelable deinits? It cancels. So if you don't hold on a reference to it, it just gets reclaimed and goes away, and that's it.
Okay. Wow. Interesting. It's like good housekeeping. Yes.
Yeah.
So are you sure that in like the OS automatically cancels all requests?
So what do you mean exactly? So it cancels.
So you said that like once this is deinitted and cancellables is destroyed, you will lose. Because I'm okay. I might have been mistaken. I was like automatically doing it for each cancelable and just canceling each one.
Oh, like in DNet?
Yeah.
Yeah, you can just delete that. You shouldn't. You don't need to do it because yeah, when the cancelable gets deinitialized itself, it will cancel the request. Now that said, it is possible, like timing wise, that it doesn't get canceled until after your object has gone away. And that can be pretty weird. So unowned, it's actually safe in this case. I'm like very certain through trial and error more than anything. But if for receive completion, unowned would not be safe because when the cancelable gets canceled, I believe it emits a completion event. And by the time that happens, your object may be gone. So in that case, you would need to use weak self. So that's another, so if unowned, which doesn't up the reference count and it just says it's going to be there, I could also use weak, and now self is an optional value. And to do something like this, I would have to add this question mark, and this should work. If this were receive completion, I think is what it's called, instead of receive value, that problem you just mentioned, well, in a roundabout way, what you mentioned it would be pretty relevant because self still or would have gone away by the time receive completion executes, and the unowned, if this were unowned, it would cause a crash. So I'm not sure if you ran into something like that that made you think, oh, I've got to cancel these. Yeah. So was it receive completion?
Yeah, actually, you're right. It was.
Yeah.
And I thought it was because I like wasn't canceling my request when they were like navigating away or dismissing the view. Okay.
Gotcha. Yeah, and no, you were probably it worked. What you did worked because you were just hitting it earlier in the cycle before your object actually got deallocated.
Okay.
And actually, probably the act of you doing that kept it from getting deallocated. So yeah, if you think about like how that has to work in the system and the order in which it deallocates things, and then it gets especially weird if you have asynchronous tasks running, that even if you cancel these, sometimes the work is going to continue. It's just not going to have anywhere to go.
Cool.
And then once it's done, it'll finish and be deallocated. That
makes sense. You should see what the stack trace looks like on like the crash report for that bug. It's like there's no context.
Yeah, that's something. Oh, I should probably talk about a little bit. I really like reactive streams, and I've been doing this for a few years. But I still run into problems sometimes debugging it, and I think that's something folks who are new to it especially complain about or worried about and have concerns. And I think it's totally reasonable. I don't have like great tips and tricks around that, and nothing we can talk about in the next few minutes or tonight. But here's a super easy operator that helps. Print. So if you just call print here, anywhere in this reactive stream, it's going to tell you what's emitting at this step when anything happens. It can be very useful. Say you're not sure which step is causing an error to occur for whatever reason. You could add prints between everything that's happening, and it actually shows you. Let's see if we can see the output. So it's telling you like which operation is happening at each step. So you can kind of match up what's going on And I want to say, let me click in here. I think you might be able to add even more. Yeah, so you can add context if you want. So it actually takes some parameters. So that helps you kind of track down problems. And I know it feels very old school because for the last, however many years you've been a professional developer, you've probably been like, oh, I've got to learn my debugger, and I'm using my debugger, and getting further from using print statements, which I think we all probably started with. I know I did. And yeah, and I'm telling you, oh, if you want to test your or debug your combined code, just add print statements everywhere. I think those are pretty safe to add. I think they're safe to leave even in for production. I believe they get, not that iOS app logs are very susceptible to being read by nefarious parties, but I think they're pretty safe to leave in production. I think they get, they actually don't print anything to the system console in production builds. I'm not 100% sure of that though, but I think it's pretty safe. You can just add those, and yeah, it's pretty useful for debugging. Any other questions? All right, if there aren't any other questions, we can just talk about random stuff. We can try to work through this bug.
You clicked resume. Now click play. Like after you click resume, it's like,
oh, where? Here?
It's a dance. Yeah, click resume and then go click play. Maybe. Yeah. You got something, didn't you? Or it said.
Yeah, but shouldn't it repeat 100 times if it works? So
that's the bug.
Yeah.
Well, the bug, it's not actually showing any. So let me. Yeah, so I don't think it's this repeat. Why? Okay. Let me see. All right. So yeah, I'm just going to send the preview animate through there once. Go here. Not getting anything. So I think the problem's actually in our model here. So let me try to dumb it down a bit. I'm going to get rid of this, this, and this. Let's see if that builds. Anonymous closure. Let's see. That should build. Okay, so what I've done is I got rid of dealing with the query, and I'm just sending an empty string through. I don't really care, which means we've broken the actual app. That's okay. Now let's see.
As long as your previews work.
Yeah, as long as my previews work. Okay, so yeah, the preview works now. So I'm gonna go ahead and get rid of that. Let's put the repeat back. I like this repeat element, so I just look for any excuse to use it. And there's not a lot of reasons to do it in production, so it gets in my preview code. All right, so that's working. Let's bring it back. So this is what we.
Preview
I'm
code?
sorry?
You have to discard the preview you build for, like.
What about the preview code?
You have to discard the preview code, or does that get built into the? Oh yeah. Is there like
like, is my preview code in my production binary?
Yeah.
Is that what you're asking? Yes. But you can do something like this. And this will only exist in debug builds.
Oh, nice. Okay.
And Apple actually, that used to be the default, and they got rid of that. And I want to say the reason they got rid of that, sorry, and when I say it was their default, they would default to putting those if debug guards around the preview providers. They stopped doing that, and the reason is because this actually goes away in your production build, which is cool. That's super useful, but if I want to have like clean separation of my debug service layers or my preview service layers, Apple isn't doing anything fancy to get those out of my binary. So it'd probably be good. We're talking about best practices. That would probably not be a bad thing to do. That said, if you want to make things more complicated on yourself, one thing I like to do and have done it with different levels of success in apps is to add debug menus that would allow like the live running application to use my preview data or any mock data set. And I might only do that for specific environments or whatever. But in those cases, I probably don't want to guard the preview data. So, but yes, it's possible to do that. There may be reasons you don't want to. All right, so back here, let's see, we got this building again. This should work. Oh, except that we made it error every time. All right, so yeah, our search service is working again. And we should have broken our preview again. Did. Yeah, so I'm really not sure what's going on here. So stick around if this isn't boring to you. Feel free to heckle me or provide suggestions. Yeah, so we've got this query which starts as an empty string. We're getting the projected value of that, so it should emit something right away because it should already be this empty string saying debounce. Well, so wait essentially for 0.3 seconds. And I think I tried just getting rid of that because I think to Matt's point, that seemed to me like a possible culprit because the previews don't like waiting for asynchronous stuff. But yeah, that didn't fix it. So it's calling through. I'm going to try to put a breakpoint in here and see if it actually does anything. I don't think it does. Yeah, nothing. All right, let me try something else. And I didn't actually go over this before, but we can launch the app. Like I mentioned, Adam, you were asking about the preview service. We can use the preview service in the live application. So I'm going to do that now. So now I will be able to put a breakpoint in here. Okay, and my breakpoint fired. And my data's there. Okay. I don't know. I don't know then if it shows up here. What's that?
It's just heckling. But it's that should say Jim is upset. What happens next instead of the
No, you're absolutely right. I am upset. Yeah, okay. I don't know. I think this is a bug with Xcode, the preview tool. Then, do y'all want to stick with me for a second? See if I can get it running in Xcode 12.
Yeah, do it.
Let's see.
But if Xcode 12 is not here to save you.
Oh, this is still 11.6. Yeah. And so it's going to be the Xcode 12 beta, so it's probably real bad.
Is this, wait, what version of Xcode are you using now?
I was using 11.6, which is one major and one minor version old. Let's see if this even compiles with Xcode 12, hopefully.
There it is.
Who is playing the Jurassic Park music? Is that Matt?
Oh, sorry. It's my wife listening to someone play it on 8 cellos dressed in a dinosaur costume.
That's incredible. All right.
Yeah, if anyone's interested, it's Samara Ginsburg on YouTube. She does a whole bunch of videos like it with like she does like the Mario theme, a whole bunch of different stuff, and like
Nice.
various funny costumes, and kind of like her like kind of playing all the different channels, but she does it all on cello.
I love it. All right, I'm gonna put that in the chat. Oh, Matt asked a question a while back that I didn't see, so ignored. The sum keyword. No, I can't explain it.
I was just trying to ask the gimme. I kind of understand it.
I think it's weird. I can take a shot. I wasn't.
It's to make the compiler happy.
It is. So